Let's continue our study of access control by looking at a set tutor. Here's the problem statement. Write an interactive tutor to help students learn set operations. The operations that we're going to use are union, intersection, set difference, element of, and complement. Don't worry if you don't know what these operations are. I'll explain them. So first let's introduce sets. So sets contain elements from something called a universal set. In other words, the set of all possibilities. So this could be written, for example, in our case, a set containing 0, 1, 2, and so on, up to 10 for this tutor. They're denoted by curly braces separated by commas. So notice curly brace, 1, 3, 5, curly brace. The order of the elements in a set is not important. So the set containing 1, 3, and 5 is the same set as the one containing 5, 3, and 1. The set elements are not repeated. So for example, the set containing 5, 5, and 5 is the same set as the set containing 5 and 5, and it's the same set as the set containing 5 alone. The first set operation is union. This is all the elements that are in one or both sets. So if we take the union of the set containing 1, 3, and 5, and 1, 4, and 6, we get a set containing 1, 3, 4, 5, 6. Notice that I didn't repeat the number 1, even though it's in both sets. I could have repeated it and it wouldn't have made any difference, but it's a little more clean to not repeat it. The intersection is the elements that are in both sets. So if we intersect the set containing 1, 3, 5, and the set containing 1, 4, 6, we get the set containing 1. With the set difference operator, the elements in the second set are removed from the first set. So if we take the set difference of 1, 3, 5 and 1, 4, 6, we get 3 and 5, because those are the elements that are in the first set that are not in the second set. So notice the set difference operator is not symmetric, whereas union and intersection are. There's a special set you need to know about. It's called the empty set. It's the set that doesn't contain any elements. It's sort of equivalent to 0 in mathematics. Now you may not know this, but in the history of mathematics, 0 was invented centuries later than counting numbers. That's sort of counterintuitive for people who grew up knowing about 0, but actually the need to not count anything is something that was realized a lot later than the need to count things. So for example, if we take the set difference of 1, 3, 5 and 1, 2, 3, 4, 5, it gives us the empty set. The complement are the operations that are in the universal set that are not in the given set. So the complement of 1, 3, 5 is 0, 2, 4, 6, 7, 8, 9, 10, all the other elements. There's also an operator called element of. 3 is an element of 1, 3, 5, but 3 is not an element of 1, 4, 6. So we can see that element of is a Boolean operator. So we'll get lots of practice on these operations if we're testing if you haven't seen them before. First, let's design some test data. Now, because the data is randomly generated, we need to be sure that our tests are exhaustive. We need to be sure that every operation is tested several times, not just once. We also need to make sure that empty sets and universal sets are working properly. These are our boundary conditions, so we know that they can be problems. And we need to make sure that when users enter repeated data, that the data is processed properly. Because it is legal to have repeated data in a set, we have to make sure that things are working correctly in that case. So those are good boundary conditions. The next thing we need to do is design our set class in UML. For instance data, we could use an array list or an array. Either would be fine, but I've picked an array list. For our class data, we're going to have a limit of 10. Now this is class data instead of instance data because it's going to be a constant. You can tell that I'm thinking of it as a constant because I've used all caps. We also need some constructors. We need something called a copy constructor that creates a copy of sets. You'll see why we need that in a few minutes. And you also need to be able to construct an empty set. Now here are the signatures for the 5 operations. Remember that these are instance methods, and instance methods have an implicit object. Now we could have written these as class methods if we wanted to. That would be a different set class, and in fact we could have put both the instance methods and the class methods in a single class. So this is what the signature would look like for instance methods. For union, for example, notice we have only one set parameter. The other set parameter is the implicit object, and it's going to return a set. So the union operation is not going to change the implicit object. Again, this could have been done differently, and it's extremely important that we document it correctly in the code so people know what we were doing. Similarly, the intersection method takes two sets, one the implicit set and the other the parameter source, and returns a set. Set difference also takes two sets. The implicit set will be the one that's being subtracted from, and source will be the one that's subtracted, and that returns a set too. The element of operator takes an integer parameter. Now we could have made this an int parameter too, but because we're storing integer objects, using an integer makes more sense. It returns a Boolean, as we mentioned before. The complement operator doesn't have any arguments. That's because it's going to take the complement of the implicit set, and it will return a set. We also need to consider our Java idioms. We'll need a toString method, and that's going to create a string. So that's how we'll do output from this set. Notice that we're not putting in anything that prints to the command line. Because those things tend to be very specific to a particular program, we don't want to use those when we're trying to create reusable sets. We'll need an equals method that compares two sets. Now remember, we're going to have to be careful in this equals method because there's no guarantee that the set elements are in the same order. What's more, we have to be careful for repeated elements. Now our sets aren't supposed to have repeated elements when we store them, so there'll be a lot to think about. Another thing we might want to consider is what will happen if source is null. Now null is different than an empty set. Remember, null means that the object wasn't constructed. So when you construct an object and don't put any elements in it, that's when you get an empty set. But when you don't construct an object, that's when you get a null source. These are two separate cases that we're going to have to consider. If we consider a method called parse that will take a string and create a set object, we might want to consider what its signature should look like. So certainly the parameter is going to be a source, but should it be static or not? Should it be void? Should it return a set? Any one of these is possible. For example, we could make it similar to the parseInt method in the integer class. In that case, it would be static and it would return a set. We could also make it an instance method. If it's an instance method, then it's going to return void and not be static. Either one of those choices would be possible. I'm going to make it an instance method today, but we'll talk about whether that was a good design decision later. The next thing we need to be able to do is to create random sets. Now this could be a class method. For example, public static set make random set would be one possibility. It also could be an instance method. So that would look like public void create random set. Notice here the implicit object is the one that will be initialized. We also need to have create random element. That will be a class method because it doesn't require a set object of any type. Now we have a critical design decision to make. Should we store repeated elements or not? This is a critical design decision. This is something where if you make the wrong decision, you're going to make your job enormously harder than it has to be. So we want to make sure we make the decision that keeps the logic as simple as possible. Well, repeated elements make the logic much more complicated. We're going to definitely not want to store them. This also has the benefit of keeping the array list a little smaller. Because our sets are so tiny, that isn't really a very important design criterion. The main criterion is keeping the logic simple. This is going to require constant thought when we're developing methods. If we put even one duplicate element in to a place where we weren't expecting it, none of our methods are going to work. So we're going to have to think about this all the time. To make this easier, I'm going to create a method called private void remove duplicates. And its job is going to be to check through a set and make sure there are no duplicate elements. If we call that at the end of other methods, assuming it's running correctly, then we know that we won't have any duplicate elements. Now notice this is a private method. This is not something we want people outside of the class to be aware of. In fact, if you'll notice, people outside of the class don't have any idea that we're using an array list to store this data. We'll talk more about that design decision later. Now it's time to implement some of our set. So we'll implement the default constructor, the equals operator, the toString method, the intersection, and remove duplicates. So that will give us a nice cross-section of methods to look at. Here we go to Eclipse. So here's our set class. Now our universal set goes from 0 to limit. One thing I see about the documentation I wrote is that I wasn't specific about it being inclusive. That was a mistake. We definitely want to fix that. So here we have class data that's the limit. Now the reason the limit is class data is because it's a constant. When we have a constant, remember there's no reason that each object needs to have its own copy because constants can't be changed. So one copy can be shared through all of the elements. What every instance does need to have is an array list of integer called elements. So that's our instance data. Now the first thing we were going to do is to construct an empty set. Notice that the goal of all constructors is to make sure that the instance data is properly initialized. Well, our only instance data is elements, the array list, so let's initialize that. So there we go. One of the things that I do when I'm building constructors is methodically look over every single piece of instance data and make sure that everything is set up correctly. Now it's not very hard in this case because we have only one piece of instance data, but in general that's a good rule. Now this is another constructor that I created for you, and here we have a copy constructor. Let's look at that one in a minute because that's one you don't see as often. So what you're doing here is it's a constructor. You can see it's a constructor because it doesn't have a return type and because it starts with the name of the class, set. What makes this one different is it's copying a set. Now what we need to be careful of here is to make sure that we actually copy the data in old set. What we don't want to do is say elements equals old set.elements. Let me write that code for you to look at. So that is wrong, wrong, wrong. The problem here, aside from the missing S in elements, is the fact that what you're doing is sharing a reference between those two sets, which means that if you change the elements in old set, the elements in the set you're constructing will change too. That is the kind of error that is incredibly hard to find in code, particularly since people often forget to look at constructors as possible sources of bugs. So what we needed to do was to create a new set of elements from the old set. Now there is a method in the ArrayList class called addAll that makes it possible to copy the elements over in one step. You also could have done this with a for loop if you prefer to do it yourself. Here's our remove duplicates method. So we need to think about how we're going to do that. We need to step through the elements one at a time and make sure that they don't match any other element. If you think about it, you could draw it sort of like a triangle, where the first element steps through all of the other elements, the second element steps through the ones that are further on, the third, and so on. When you have that kind of organization, it is a nested for loop. So that's what we're expecting. Well, actually, it's just a nested loop. The fact that I'm going to do it as a for loop is a personal preference. So for int item is 0, item less than elements dot size. Remember, this is an array list, so we're using array list methods, plus plus item. So what we're going to do inside this loop now, make sure that this item is not equivalent to the other items. So that's another for loop. So I'm going to call this test, and it's going to start at item plus 1. We don't need to start at 0 because we know we've already checked the items that are before this one. So now item is going to be less than elements.size. Whoops, not item. That's test. Plus plus test. Now one thing you may notice here is I didn't call my indices I and j. I did that for a particular reason. When I was programming, the worst programming mistake I ever made in my life, one that cost me 6 weeks of time, was made when I was doing my doctoral dissertation. I actually reversed an M and an N as indices in code and couldn't find it forever. Now, as a result, I don't tend to use a lot of single letter variable names. Okay, so now we have two for loops. We need to compare the elements and see if they're equal. So if elements of get at an item is equal to elements.get at test. So that means we found a duplicate. So in that case, we need to remove the item. Looks like I've forgotten my S in elements again. So now we need to think very strategically about how we're going to do that. Because when we remove an item, remember, we're going to change the size of elements, and that's going to mess up the loop. So if we remove the first one, then we've got a problem. So we definitely need to remove the second one. So we'll do elements dot delete of test. Now for some reason it's not liking delete, so let's go to the API and see what the method is really called in the array list. So here's our array list class. It's probably called remove, but it never hurts to look these things up. Remember that there's not a lot of value in memorizing these methods when the API is so convenient. Ah yes, and we can see that the method is actually called remove. Now we have to think carefully about what we're going to do with the index. The problem is that, remember, when we remove an item from an array list, the rest of the items shift over to the same spot. So we need to make sure that when our list starts up, it's checking that first item. In other words, we're going to have to reset our counter test. So test needs to be reset to item +1. Now let's think about that for a minute. When we get to the end of the loop, test is going to be incremented because that's how for loops work. So if we put item +1 in here, at the end of the loop that will be incremented to item +2, and that means we're going to skip an element. So it really needs to be initialized to item. So let's clean up the code and document it a little bit. The method has a void return type, and so there's nothing else we need to do here. Now, one thing we might want to do at this point is test a little bit. Now, I don't want to use the full tutor because I haven't talked about how that's designed yet. So we could create just a little dummy test to experiment with it and see how things are going. The only problem with that is we haven't written our toString method first. So strategically, it probably would have been wise to write toString before we wrote some of these other methods. So let's go and do that one next. We're scrolling past some of the other elements that I've already written for you. Of course, one way that we could have gotten to this a little more quickly is to take advantage of Eclipse. We're right down here in the set tutor, so let's open that up and open the source code and the default package and the set class. Remember that it has lots and lots of methods. One of the things that you can notice is that Eclipse is actually documenting some of the elements of Java for you. For example, this S, that stands for static, and that really helps. On limit, notice we've got static, and we also have a capital F, which stands for final. Elements was our instance data, and it gets a little red box. The solid red box stands for a private method. So the C's here, that stands for constructor. So notice that Eclipse is giving you a lot of help. One of the ways that you can use this in programming is to make sure that things are what you think they are. Let's say, for example, we had made one of these sets, made one of the classic programming mistakes of putting a return type. Did you see what happened in Eclipse? It moved this constructor now and is showing it as an instance method. Well, the reason it's seeing it as an instance method is because we have a return type here. So actually, Eclipse can help you find some of the really hard mistakes that you can make in programming. From this view, we can click on the toString method, and Eclipse will take us there quickly. What we need to do here is to return a representation of a set. Because this is the only way we have of outputting the elements in the set, we need to make sure that we do it in a way that's attractive. So I'm going to do it with curly braces and commas. And we need to make sure that it really looks nice, because we don't want other people to have to clean up our work. So first I'm going to create a string builder. The reason I'm making a string builder instead of a string is because we're going to be building this up a piece at a time. I could do this with concatenation using the plus operator, but this is just a little nicer way to do it. So here we have an empty string builder. The first thing we want to do is to append our first curly brace. And of course, it helps if you spell the method name correctly and use the right number of parentheses. So now this has a curly brace in it, so we need to put the elements in and the commas. So that's going to be a loop. So the index is going to be less than the elements dot size, and of course we'll increment it. So now we'll do result dot append elements dot get of index. The comma is a little bit different though. We have to be careful not to put a comma after the last element, because that doesn't look right. That isn't how sets are done. So we need to check and see if we're at the last element. So if index equals elements dot size minus 1, well, at that point, we will do, oh, I was going to put the comma in here, but the logic is actually reversed. We want to put the comma in when it's not equal, not when it's equal to. So when it's not the last element, we'll do result.append elements dot, whoops, not elements, a comma. Now I made this one a string when I made the other one a character. Doesn't really matter so much. But let's be consistent. Always striving to have our code be as beautiful as possible. So as long as we're not at the last element, we put in a comma, and then at the end we do result.append. Our second curly brace. So there we go. Now, remember that our return type is string, not string builder. So we need to return, not result, but result.toString. Now, we haven't documented this much, so let's actually add some documentation before we move on. So we're going to add the elements to the string builder one at a time, and this one definitely needs some documentation. Don't put a comma after the last element. Well, thankfully now we're at a position where we actually could test this class a little. It's always a good idea to create these little dummy classes that allow you to test things. So I'm just going to call this dummy test, put a main program in it, and exercise our sets a little bit. So we'll construct a set. So that's our default constructor. Now we need to find a way to put elements in a set. So we need to take a look at some of our possibilities here. Remember we had a parse method that read input from the keyboard? That's a good one to use. So we'll have set1.parse. Now in this case, we aren't going to actually read from the keyboard. We're going to just put in a set. And then we'll do system out println set1. Notice we don't have to actually call toString because it's called automatically by the print line statement. So this would give us an idea of whether our constructor and whether our toString method are working correctly. Now, it isn't going to tell us anything about our remove duplicates method because we haven't actually called that method. So we'll have to do some more testing in a minute. But let's just run this for now. So this is my test early, test often strategy. So our set's looking pretty good. We might think about whether we wanted some extra spaces in there just to spread this out a little bit. It would be okay either way. Maybe it looks fine just as it is. So let's now check our remove duplicates method. Now the remove duplicates method was called by the parse method because anytime you're reading things from a user, you can't trust them to follow the rules. Besides, it's actually legal to have multiple elements in a set. We just don't want to store our data that way. So this is the kind of data. In fact, let's even make the test a little bit harder. Okay, so we know what we want here. We want a set that contains just 1, 3, 5. So let's see if that's working. 1, 3, 5. Looks like our parse method is working well, and it also looks like removing duplicates is working. So we did a good job on that method. That's actually a tricky method to implement. So let's go back to our set class and find our other methods. We were going to implement an intersection method. Which is right here. Now, the intersection method is returning a set, so we need to create that set. So I'm calling a constructor. At the end, we're going to return it. By putting that in now, we'll get Eclipse to stop freaking out and putting things underlined in red. So now we need to think through the strategy here. We need to step through both of these sets and see if the elements are the same. So if we have any elements that are identical, we need to make sure that they get included in the intersection. So we have a nested for loop again. So I'm going to say implicit is 0 and implicit is less than elements dot size plus plus implicit. Now the reason I'm calling it implicit is because this is the index for the implicit set. Remember that because this is an instance method, that means there's a set that's hidden around in the background. It's called this. Now some people find it easier to actually say this.elements.size, and that's perfectly legal. If you find that easier, I encourage you to do it because it reminds you of which set we're talking about. Now, our nested loop is going to have to step through the other set. That's the one that's called source. So int, and I'll call this source index, is 0. Source index is less than. Now, at first you might think, hey, wait a minute. Our source method doesn't have any kind of index method. It doesn't tell me how many elements, so how am I going to be able to work with this? Well, we're inside the source class, so we have access to the private data of the source object. So we can do less than source dot elements dot size. And of course, we'll increment source index. Now you can see I've gone off the screen here. So of course, we always rewrite that method so that we can see all of the data that's on the screen. And let's put some comments in here so we know which loop we think is ending in which curly brace. Okay, so what we need to do is to compare these two elements. So if elements.get of implicit, now we need to think about this comparison. Do we want to use equals equals or do we want to use dot equals? Well, what we're comparing here are integer objects, not int objects. Integers require dot equals. So this will be elements.get of source index. So when those two are equal to each other, that's when the element goes into the intersection. We'll do result.elements .add elements.get of implicit. Now it looks like Eclipse is freaking out over something, so let's see what it's complaining about. Oh, I see what the problem is. I spelled it wrong. That'll kill you every time. Okay, so now we're ready to go forward again. Notice that I did not jump at what Eclipse was saying immediately and remove that and put in equals equals. I knew it needed an equals method, and so I wasn't willing to give up on it. Those are things you need to do, is to learn to trust your instinct on code. The next thing we need to consider is whether there's any way we could have put duplicate elements in. Because we're going through each element with every other element in the set, assuming that the sets don't have duplicate elements, we should be okay. But on the other hand, it never hurts to be extremely cautious. We can call our little private remove duplicates method. Now, if you think that I'm being excessively cautious, absolutely. Remember that when you see a good computer scientist, just like a good statistician, they're going to be wearing a belt and suspenders. We are cautious people. Why not? Now, I am going to document. This should not be necessary if neither of the sets has duplicate elements. But it doesn't hurt to be cautious. Frankly, because the sets we're working with are so small here, the expense of calling a method like remove duplicates is not something we really have to worry about. So here we're getting extra error checking, extra assurance that our code will actually work, and also making sure that everything is just perfect. So that's a good investment, even if it turns out that we don't have any duplicates in it. So let's go to our dummy test and try out our intersection method and see what happens. So we're going to need two sets. And let's parse in something for set 2. So we want something that has an intersection, but we also want something that isn't going to intersect. Of course, as always, we need to be thinking to ourselves about what this should give at the end. So let's think about that. Because we're intersecting a set that contains 1, 3, 5 with a set that contains 1, 3, 4, 6, 8, 10, we should get a set that contains 1 and 3. What we're going to print out here now is set 1 dot intersection with set 2. Now, think about what we're doing here very carefully. Remember, this intersection method is returning a new set, and that set is the one that's being printed out. Let me show you another way to write this code, something that may be easier for some people. So we can actually store the result of the intersection method in another set and then print out set 3. Don't be afraid to do things like that. It really helps sometimes if you know exactly what type the variables are, so I encourage you to do that. Uh-oh, we've got a problem. So remember, when we debug these things, we go back to the last line that we wrote, which is 171, and let's see what's going on here. So it's complaining about not being able to find one of these two methods. So let's check and make sure we've got the right indices in the loop. So we start implicit at 0. We go to less than size and increment implicit. That looks correct. We started source index as 0. Go to less than source.elements.size and then increment source index. So what could be going wrong here? Well, one thing we can do is we can use our debugger to tell us what's going on. So let's go to debug mode. Now we know the problem is right here. So the place we want to stop is at this line so that we can check things out. Now we may want to think about whether we want to make our example smaller, but let's run it as it is right now. So remember, when you run in debug mode, you use the little bug. And we're going to look at source. So here is its data. We can see that it has 5 elements. So there's 1, there's 3, there's 4, there's 6. So this is our second set. Notice that these are null, so those are not the values we're looking for. So we can see that we're getting the right things in there. So that set looks perfectly fine. Now the other thing we want to look at is in this. So let's go and look at its elements. Now we're expecting to see 1, 3, and 5. 1, 3, and 5. So those values look okay. So let's continue a step and take a look at what's happening in the data. So we've got everything displaying. So we see that implicit is 1 and source index is 0. That looks fine. 2, 3, and then it went out of bounds. So we can see what happened is that we went out of bounds on one of those array indices. Okay, so that tells us what's going on. Let's go back and debug our program a little bit now. Now notice that the debugger has taken us into the ArrayList class. Remember that this is not where the problems are in our code. ArrayList is part of the standard Java API. This is not the problem. Let's go here and take one more look at the code. Okay, 0, less than size, increment implicit, 0, less than size, increment source index. So notice that I've been paying a lot of attention to those for loops, but not paying so much attention to the if statement. That's kind of foolish because the if statement is actually where it's breaking. Take a look at what I did. Elements.get, elements.get. Well, I wasn't supposed to use elements here. I was supposed to use source.elements. There we go. I bet our code's going to run better now. So we have 1 and 3. So it looks like our intersection code may be running correctly. So the last method we need to write is equals. So let's go and find that one. And here's our equals method. There's some special cases we have to consider here. First off is source is null. Now remember, null is not the same thing as the empty set. When an object is null, that means it hasn't been constructed. So this is an odd case, but it's one that we usually take care of in equals. Now there are some technical reasons for this that you'll understand a little bit later in programming. But for right now, I just want to make sure that I'm modeling the best practice for you. So if source is null, what we do is we return false. Now the reason behind that is because if it's null, it can't be true. There's no way that you can call an equals method on a null object. So if the parameter is null, it definitely can't be the same thing. Another style thing that I should mention while I'm doing this is when we have these little tests to see if the arguments are legal, what I try to do is put them at the top of the method and return from them. So if the test fails, get out of there. This prevents getting a lot of deeply nested if statements that make the code harder to read and harder to understand. It is a little bit tricky at first, because if you don't realize that there's sort of an implied else in this code, you might think that I'm still going on in it. But you'll get used to it once you see this convention more. The next case we want to consider is what if the sets have a different number of objects? because if the sets have a different number of objects, well, guess what? The sets can't be equal. Now notice this is only true because we removed duplicates. If we hadn't removed duplicates, this would not be true, and our task of writing equals would be a lot harder. So if this dot elements dot size is not equal to source dot elements dot size, this means that the two have different numbers of objects. We're going to return false. So if we get to this point, we know that the sets have the same number of objects. What we need to do now is to check and make sure they have the same objects. So to do that, we're going to look and make sure that every element in set 1 is in set 2. Now, if you're the cautious type, you might say, well, why don't we also check and make sure that every element in set 2 is in set 1? Well, when you don't have duplicates, if you have the same number of elements, you don't have to do both of those checks. One of them will suffice. Of course, as you know, I'm not opposed to doing a little bit of extra checking, so if it makes you happier to do both of them, by all means be my guest. So we'll do implicit is 0, implicit is less than elements.size, increment implicit. And of course, once again, we've gone off the screen a little bit, so we're going to pull that back. Now for source index is 0, source index is less than elements dot size, increment source index. So this steps through both of our elements. So now we need to think through the logic. Do we want to do something when we find objects that match or when we don't find objects that match? Well, it turns out if we find an object that's in the first set that's not in the second set, we're actually done. That means that these sets are not equal to each other. If elements.get of implicit is not equal, now we need to think, do we want to use exclamation point equals or do we want to use dot equals? This is an integer. So since it's an integer, we know dot equals is what we should use. To source dot elements dot get of source index. Now our lines of code have gotten a little bit long here, so we need to think about where's a good place to break it. I think probably the best place is right there, just in terms of being able to see all of our code. If they're not equal, if we find an element that's in elements that's not in source.elements, we need to think through this a little bit more carefully. We shouldn't be comparing individual elements. We should be looking to see if the element that's in the implicit set is somewhere in the source set. Well, let's think about it. There's a method in the array list that does it. It calls contains. So let's not go and reinvent the wheel here. Let's use what's available. So if elements.contains, source.elements contains elements.get of implicit, well, is it when it's contained that we want to do something or when it's not contained? So if we find an element in the implicit set that's not anywhere in source.elements, notice not, that's where that exclamation point comes from, that's when we're ready to return false. Now one thing you'll notice is this is still a nested loop. It's just the other nested loop is in the contains method. It was written by the people who write the array list. So let's see what Eclipse is unhappy about. Looks like I may have cheated it out of a parenthesis. There we go. Now, if we get all the way to the end, source wasn't null. It had the same number of elements, and there's nothing in elements that isn't also in source. Guess what? That means that equals is true. So that's where we should return true. And notice that removes Eclipse's last problem. Let's go to our dummy test and test this method just a little bit. So now we're going to do set 1 equals set 2. Now this is not a set operation. So we're going to need to store the result in a Boolean and then print out that result. Now at this point our two sets are not equal to each other. So that's definitely a case we should check. Well, that was interesting. Let's just run that again. Okay, so I don't know exactly what Eclipse was thinking right there, but it's now thinking the right thing. Let's check a case where they are equal to each other, just to make sure we've covered all the ground. Eclipse is having a bad day. So here is true. That looks good. One thing we might want to try is an empty set. You know, that's one of those nasty little boundary conditions that tends to show up. Don't know what its problem is, but running it twice seems to be working. And in fact, that's correct. So it looks like all of our methods are working well at this point. Let's talk a little bit about some implementation notes. We had to constantly think about what kind of object we were using. So notice, for example, when we had the set as a parameter, then we had to use set.elements because the set is a set. It's not an array list. So we can only use on the set the things that are in the set class. If this gets confusing for you, one thing you can do is to declare variables of the given type and assign them. I found that this helps students who are struggling with the difference between different types of objects to understand how these things work. Always make sure that you differentiate the implicit object from the parameter objects. One way to do that is by explicitly using this every time. And if that makes you more comfortable, there's no problem with using it. Also remember, do simple operations instead of compound operations. I sometimes will nest operations 2 or 3 levels deep, but when it gets any deeper than that, it's very hard to read and it's very hard to debug. So keep it simple. The next thing we need to consider is the design of the tutor class. For instance data, we should have the number of correct and wrong answers. Because remember, the tutor class is just going to be checking on whether the students have done the set operations correctly. We also are going to need to have class data that stores the number of times the tutor should be run. Now we also could ask the user to enter it, or we could generate it randomly, but this is an easy way to do that. There also should be constants for the operations. Now the reason we do this is to keep the code maintainable so we can add more set operations on if they come in later. The main method could be put in a separate class if we wanted to, but if we did that, we're going to have to create accessors and mutators for the number of correct and wrong answers. And there's really no reason to do that. So I'm going to put the main method in the same class. Now there's some tricks to doing this, so pay attention to how it actually works. The other thing we'll need, of course, is a constructor, because since we have instance data, we have to be able to construct it. Our last method is going to be show and test random operation. Now this method actually got fairly long when we were doing it, and we'll talk about whether that's a problem later. This will return true if the student answers correctly and false otherwise. So basically this method is hiding all the details of how the student does the set operation successfully. Now, why is this a class method? That's really counterintuitive. Well, the reason is because we're returning a Boolean that tells whether the student was successful or not. We don't need to update the instance data, which is the number of correct answers and the number of wrong answers. So that's why this is a class method. Now, the way to tell this when you're implementing it, if you didn't get it right in the design, is to recognize that you didn't use the instance data in the method itself. Now, this dummy test program we may want to keep or we may want to get rid of eventually. For right now, I'm just getting it off the screen so I don't get confused by it. So here's our tutor class. We have 2 pieces of instance data, the number of correct answers and the number of wrong answers. Now notice these are instance data, so we're going to have an object from this class. We also have a constant for the total number of exercises. Now I made that constant public because I think people outside of this class might want to use it. Now, you could also make it private. In general, it's better to always make things private if you can, rather than make things public. So you could go either way on this one. It never does any harm, really, to make a constant public. Since a constant can't be changed, there's no risk. But on the other hand, you want to be very judicious about how you do it. Once you've made something public, you can't go back to private. So notice that when I was creating constants for the 5 different operators that we're going to test, I did make those private. This is the internal logic of the program, and nobody else needs to be privy to that. So those constants definitely don't need to be public. Let's take a look at what our constructor does. Remember, the goal of a constructor is always to initialize the instance data, so it sets the number of right answers and the number of wrong answers to 0, just like it should. Now here's our main program. So we need to think through what we need to do. Well, we're going to need to create a tutor object, then we're going to need to give the total number of exercises, keeping track of whether the answers were right or wrong, and then give some feedback to the user. So that's our goal. So let's write that down. Now this is the step that everybody forgets, is that even though we're in the main program here, we need to have a tutor object, even though we're in the tutor class. Remember, the main program is a class method. It's not an instance method. So there is no implicit instance hanging around. If we want an instance of this class, we need to construct it. To make matters worse, this is one of those things that Eclipse does not indicate very clearly. It will complain about things that really are hard to interpret. So be aware of the fact that that's a problem. So we now have a tutor object that's properly initialized. We're going to have to give the user total exercises. So let's create a for loop for that. Exercise is 0, exercise less than total exercises plus exercise. So there's our loop. As you can see, it's off the screen. So we're going to do the usual thing and move it down a little bit. Keep our code visible. We need to know what our method is going to look like. So here it is, show and test random operation. Now we haven't looked at the details of this method, but what it's doing is displaying operations to the user, allowing them to enter it, and it's returning true or false if they did it successfully. We'll look at the method in a few minutes. But for right now, we're just going to use it. It's okay to use methods when you haven't read them. So show and test random operation. And notice it's taking it needs an argument from our scanner. Don't know if I created a scanner yet. Looks like I didn't, so I better do that. So there we go. Now, this is telling whether the user was successful or not. So we better store that. And then give the user some feedback. So if result, now notice that I did not say result equals true. Result equals true actually means the same thing as result just by itself. This is really more a style thing than anything else. If you put result equals true in your code, people are going to look at your code and say, wow, did you just start programming? So I'd rather have your code look a little bit more professional. But if you need the equals true there to know what it's doing, that's just fine. But think about it. If result is true, result equals true is true. If result is false, result equals true is false. So there's no value for that equals true. So if it's true, then we'll give the user some feedback. You got it right. Users are always excited about that. We want to encourage it. Now we need to increment the number of points. Now, remember that we can't just access our variables, we call it correct answers. We can't do this, as Eclipse is telling us. Now let's take a look at this error message. Can't make a static reference to a non-static field. Now that's one of those error messages that is not very helpful. So let's take that error message apart and see what it really means. Cannot make a static reference. So you can't use a class method to get to instance data. So that's what a non-static field is. So what it's saying is, hey, wait a minute. You're in a class method. You don't have an implicit object. You have to tell me which object. Now we have the object. It's called this tutor. And notice that removes that problem. So these are the very subtle points of using class methods and instance methods together. And now let's tell the user how many correct answers they have. Okay, and we've scrolled off the screen again, so we definitely want to fix that. This one may be a little trickier to fix because we're running out of real estate, but that looks good. Now we also have to consider the case when it's wrong. Whoops, we don't need to put a test in here because there are really only two possibilities. They did it correctly or they didn't do it correctly. So let's grab our code. Probably don't want that exclamation point on wrong. May want to think about whether that's polite or not. Of course, as always, when we cut and paste code, you need to read it very carefully to make sure that you get everything, that you get all the comments and everything correct. So let's be a little nicer here. I'm sorry, but you got it wrong. Remember, never pays to be rude to anyone. This has gotten long and it's off the screen. So the way we fix that is this. Remember, it's not legal to break a string over lines. That's an annoying little Java thing. And you can also see we need a space here because we want a space between the word it and the word wrong. Okay, so when we get to the end of the tutor, what we want to do is to give the user some feedback. Now, we have not marked which curly brace is which, and because our code has gotten a little bit longer, it's probably a good thing to do. So this is the end of the for loop. Now we might wonder why that is indented so much. And what we see is that we indented one time too many. Well, that explains why everything was going off the screen. That's annoying. So we definitely want to undo that. So to undo it, what you do is you select it, and then you do Shift-Tab, and that bounces it over one position. And notice now everything is fitting on the screen better. So this looks much better now. So let's give the user some feedback at the end of the program. You had this tutor dot correct answers, 2 hours incorrect, and system out print line, you had this tutor dot wrong answers, wrong answers. One thing we want to be sure is that they either both end with a period or neither ends with a period. So things look good. Looks like we have the spaces in the right place. So now we're ready to actually run the tutor. So here we go. Find 906 complement. if we were doing our formal testing now, we would want to write down which operations we've actually seen to make sure that we see every operation multiple times. This is really important because we're doing things randomly, which means that we might not see some of these operations for a while. So the complement operation, remember, is the elements that are in the universal set that are not in this set. So we have 1, 2, 3, 4, 5, not 6 because it's in the set, 7, 8, 9 is in the set so it's not in the complement, and then 10. Hey, I got it right. Now, something interesting happened. We've gotten a complement again. We might think about whether that's random enough or not. So 613 complement. Well, 0 isn't in the set, 2 isn't in the set, 4 isn't in the set, 5 isn't, 6 is, then 7, 8, 9, and 10. One of the problems with the program as it's written is this interface is fairly fragile to mistakes with curly braces and commas. As you might guess, when I was parsing the input, I used that split operation again that we've used several times. So if people forget a comma, they're in trouble. So that's something we could probably improve. I'll probably make a mistake and break this program one of these times. Okay, so now we're seeing a set difference. Good to see a different operator. That makes us a little bit less suspicious. 3 is in the first set and in the second set, so it's not in the result. 6 is in both the first and second set, so it's not in the result. 2, on the other hand, is in the first set but not the second. 9 is in both, so it's not in it. 8 is in the first set but not the second. 5 is in the first set but not the second. And 7 is in the first set but not the second. Notice the fact that we have things like 0 that are in the second set but not the first doesn't matter. So set difference is one of the only operations that is not symmetric. So there we go. Now, this next one is kind of interesting because it has the empty set. So it's good to see that. It means it could be randomly generated. And also we might want to think about what our answer is going to be. Well, if there's nothing in the set, there's nothing to remove. So our answer is going to be the empty set. So this is a good test of the software. We haven't tested the universal set either. So everything's working well so far. One thing we have not tested is a wrong answer. So that's something we certainly should continue. So let's give a wrong answer here. So that is certainly not the intersection of those two sets. So let's read this carefully and make sure that it makes sense. It tells me what the correct answer is. It says, I'm sorry you got it wrong. You have one wrong answer. Okay, that looks good. Now we have another intersection coming up. Let's do this one correctly. So 6 is in the intersection. 7 is not. 10 is not. So it's just 6. This is actually another good boundary condition because it's a single element set. Okay, here's another set difference. Notice we haven't seen a union yet. That's kind of annoying. Let's hope we see one soon. 6, 2, 7. This actually is a boundary condition sort of too, because in this case there are no elements of the second set that were in the first set. So you can think of that as being another boundary. That looks like it's working well. Seems like we're getting a lot of set differences. That happens sometimes with random numbers. So 3 is going to be in the set difference. 9 is. 0 is not because it's in both sets. And 5 is. We're going to want to go back and count these and make sure. Oh, here's a complement. Good. That's another one. 1, 2, 3, not 4. 5, not 6. 7, not 8. 9, and 10. Whoops. I was afraid I was going to do that. So if you take a look at what I did wrong, I used a period instead of a comma, and the program broke. This is the fragile nature of the input. That's something that you might want to improve if you're going to work on this program a little bit. Now, we haven't seen a union yet, and we haven't fully tested, but we have seen most of our code. Oh, yes. Let's go and take a look at that random operation class, because that's sort of some interesting code. Now, the first thing I'm going to do is give you a little bit more screen real estate here, because this code got fairly long. And I'll talk a little bit about whether that's a good thing or a bad thing. The first thing I did was create 3 sets. Set 1, set 2, and a result set. Then we have an integer called element, and a string for the user input, and a result. Now I set it initially to false, but it will actually be returned when it's given a value. So the first thing we do is we pick the operation randomly. Now, we might want to think about the fact that we have not seen an element of method coming up here. That actually may be a bug in this code. If we think about it, when we multiply a random by element of, we've got a problem because when it gets truncated to an integer, it's one less. So this probably should have been element of plus 1. Think back. Did you see any element ofs in our code? We did not. So that's an indication of a weakness in our testing strategy and a bug in the program. So the first thing I did was create the random sets. Now the reason they're created this way is we created these methods as instance methods. Since they're instance methods, you have to call them from an instance. These could have been created as class methods, and we'll talk about an advantage of doing it that way in a few minutes. Then we created a random element. Now, this is kind of a weird strategy because not all of these operators have two set arguments. Some of them only have one, like element of, and some of them don't have an element as an argument. But what I chose to do here was to create all three of them at the start and then use them or not as the operation required. It keeps the code a little bit shorter and a little bit cleaner, and so that's why I did it this way. So first we have if the operation is a union, then we find set1 plus set2. So the method that's being called here is toString. That's one of our Java conventions. Then we get the user input, we parse it, and then we see if the result set equals the result of the operation. So we basically are using our equals method here to compare what happens with the union to what the user thinks happens. Then, if the user didn't do it correctly, we print out the answer. Now, the reason that I had to print out the result here is, remember, this method can only return one thing. Since we're returning whether it was correct or not, we can't also return the result. And so that forces us to print out the result here. Now, this is a case where it's not a very elegant solution. Usually we don't like our results to be printed out in other methods. We would like to keep the system out print lines in one method as much as it's possible. It just wasn't possible here. So we do the same thing for the intersection methods. And for set difference, these are all binary operations, so they have two arguments. Now complement, remember, is a unary operation. It has only one argument. So we're finding the complement of set1 and doing the same comparison. Element of is a little bit different. It's a binary operator, but it's a binary operator between a set and an element. So what we do is ask whether the element is in the set. Incidentally, this is another little weakness of this program. We're using the next Boolean method to read in the data. Now, next Boolean is not the most forgiving method in the world. We might do a little bit better by reading it as a string and then processing it ourselves to cover little mistakes. So we check to see if it's the same. Incidentally, I think a couple of parentheses there might make that a little bit easier to read. And if it is not the same, then we print out the result. Now, another thing that I've done here in this code that I strongly encourage you to do is to put an else statement in when you get an unanticipated operation. What that does is flags if you're off by one by having one too many. Now notice it didn't catch having one too few. We had to catch that by hand in our testing of the method. So the last thing we do is return the result. So it's sort of an interesting program. Now, one thing you may notice, this method ended on line 150, and it started on line 69. So this method was more than 70 lines long. That is far more than a single page. And remember, we don't usually like methods that are long like this. We could have pulled it apart into smaller methods. So for example, we could have taken these individual tests here, for example, between 94 and 99, and pass them in. But there's a reason that I didn't do it that way. The user input, you want to be very, very consistent. And when you start separating them out into different methods, then it's much harder to see if the user input is extremely consistent. So by leaving it together, I actually make it easier to maintain the code. So we don't make methods short just for the joy of making them short. We make them short for strategic purposes to make the code easier to maintain. If that strategic purpose isn't there, then we don't do it. There's always some judgment involved in these software engineering decisions. And in my judgment, having this method long makes the code easier to read and maintain than having it short. Now, if you disagree, that's okay. These things aren't absolutes. So one thing we might want to think about is, what is the class relationship between the set class and the tutor class? Is it aggregation or is it uses? Well, if you think about the tutor class, it had two instance data elements, and they were both ints, so there's no instance data from the set class. That means it's definitely a uses relationship. But remember, even if we had a set operation in the tutor class, if the set wasn't sort of part and parcel of the class, if it wasn't a meaningful component, it wouldn't be an aggregation relationship. If we're going to show this in UML, we would show it with a dotted line with an open arrowhead. When we implement the tutor class main method, remember we had to watch out for the instance and class differences. Those are things that really cause a lot of trouble. And we thought about whether the show and test random operation method should be broken up into smaller methods. That might be something you want to think about a little bit more and see what your answer would be. We've tested the tutor, we checked for empty sets. Now we didn't actually check universal sets other than indirectly. Because we did a complement operation, we did see a universal set in that. So we've kind of checked it, not really well. Of course we checked right and wrong answers. We didn't check duplicate elements though. This is why it's always good to have a testing plan, is we forgot to test that. So let's go back and do just a little bit more testing. Okay, so we see the intersection here is just 7. So let's enter 7, 7, 7, 7, 7, which by the way is a correct answer and is being recognized as a correct answer. That's good. Now here we have a set difference operation. The zero notice is going to be removed. So our answer is going to be, and I'm going to go really crazy with this one, whoops, getting carried away with those commas. Now that's actually a correct answer, albeit kind of a crazy one, and it's being recognized as correct. Now this is nice. Notice that our fix has actually resulted in us seeing that element of operation. So 8 is in the empty set. No, I don't think so. So we got that right. 3 is in the set containing 1. No, I don't think so. Now here we have another intersection. That's kind of interesting. Something actually went wrong there. Notice that I didn't enter anything, and then it went ahead. Now, if you think about that, that's going to be another one of those new line problems. So we actually did find a bug in our program by doing a little bit more testing. So we know that's going to be here. Notice we have that next Boolean. Well, just like next int and next double, that leaves the new line character hanging around. So what we have to do is keyboard.nextLine to remove that. Okay, here we go. Testing again, we've got a set difference. So we've got 10 and 6, right? That looks good. Now we still haven't seen any union operations. And you know what? I'm getting suspicious that maybe we've got something wrong there too. So let's go back and look and see why union might not be included. So we need to look and see what its constant is and then see what's going on, because we've done way too many operations not to see a union. So union is operation 0. Oh, that is painful, isn't it? Notice it's a boundary condition. So we've got a boundary condition that isn't working. Those things kill us every time. So let's go and look and see where we were choosing operations, because that's going to be where the problem is. So that's in this big ginormous method. Okay, so let's see what happens here. Math.random times element of plus 1. So we're taking a random value, which remember is between 0 and 0.99999, and we're multiplying by element of plus 1. Well, element of plus 1 would be 5, because element of is 4. So we should be going between 0 and 4.99999. That seems like it should be correct. We need to check that our parentheses are right, that these are actually being multiplied, and that the cast is occurring after the multiplication occurs, which is true. Now what I'm going to do to test this is I'm going to put in a little loop here. This is what is called destructive testing, and it's dangerous to some degree because what you're doing is actually damaging your code. So what we want to do is print this out now 100 times and see if 0 ever occurs. If it doesn't occur, then we're going to have to do some more thinking about what could be going wrong. So what we're expecting to see is values between 0 and 5, inclusive. Let's see if that's what happens. Whoops. Looks like I broke something while I was doing that. Oh, I see what I broke. Because I declared operation inside the for loop, that means our other methods can't see it. Incidentally, never try to go on and run, because if you go on and run after that, what happens is it's running old code. It's not running the code you just modified. So here's the fix. Now remember, we're going to have to undo this when we're through. Another error? Well, let's see what's going on here. It still isn't liking union. I'm sorry, it still isn't liking operation in any of these. So let's see what happened. I declared it outside of my for loop, so that's good. There's the end of the for loop. It seems like it should be seeing that. Let's see, do we have a curly brace that's out of whack? The other thing I'm doing is moving the comment over to make sure that there's nothing that's wrong there. Well, that's kind of strange. Now, I'm leaving my for loop badly indented, mostly so that I remember to remove it. Did I spell it wrong, maybe? That's always something to look for. Operation. Looks like it's spelled correctly. The local variable may not have been initialized. That's bull. It was initialized. This is one of those cases where Eclipse is being ridiculously cautious. So the way that you defeat that is just by initializing it to 0. And notice now it's fine with everything. So we have even more code we need to delete at the end. So here we go. So notice we are getting some zeros here. It doesn't look like we're getting many zeros for some reason, but that probably just has to do with the exact random number generator. So actually, our suspicion about this turns out to be unfounded. But now we know that it's true. So that's a good thing to do. Now remember, we need to remove all that code, or we're going to have problems in our program. So we had declared this as an int. We did not have that there. And of course, we don't want to leave the system out print line hanging around. The other thing we must do now is run the program again. Oh my goodness, and now Eclipse is freaking out. This probably means that we've got a curly brace that's in the wrong place. Yeah, right there it is. I told you that destructive testing was dangerous. Notice that one curly brace caused about 15 different mistakes. Bad stuff. Okay, so now we need to stop this from running, and we need to run our program again, because anytime you do destructive testing, you always need to be suspicious. So this is true, And now we're looking for a complement. So 1, not 2, 3, 4, not 5, 6, 7, 8, not 9, and 10. And we might want to do something that's wrong here. So let's just give a set with 0. And it gives the correct answer. And now it looks like things are running well. So we've actually done a little bit of debugging on our program. Of course, we're nowhere close to having completely tested this program. So we've tested our duplicate elements. Now notice the bugs we found while we were doing testing didn't actually have anything to do with duplicate elements. That is a sure sign that we have not tested this program enough. The next thing we want to talk about is whether our set class is or is not immutable. So we need to look at the methods carefully and see if there are any methods that change data. Now remember, being immutable is a highly desirable property, something that we may want to consider making the class, even if it isn't so far. Now, as far as why it's desirable, the nice thing about immutable objects is the fact that they can't be messed up. Once they've been constructed, if they have the right data, they can't be changed in any way. So for example, the string class is immutable. It does come with a downside, however. Every time you create a new set, you're going to have to create a new object if it's immutable. So we might want to think about whether this is desirable. In this particular case, because the sets we're creating are relatively small, it's okay to create many of them. But on the other hand, we might really think carefully about whether this is desirable. But first, let's figure out whether the class is immutable as we've written it and whether we would be able to make it immutable. So we go back to the set class now. So here's our set class. I'm going to go through the methods one at a time and see if they're immutable. Now remember, whoops, that's the tutor class. That's not the right one. Here's our set class. Okay, so we don't know anything about whether a class is mutable or immutable just by looking at its instance data. Constructing an empty set. That's perfectly fine. Here's constructing a set from given data. Really, a constructor can't make a class mutable because it's always building a new object. So that's fine. Let's get a little more real estate so we can see more methods. This is also a constructor. And so that cannot make an object mutable. Remove duplicates. That isn't going to make an object mutable. Now it is going to change the contents of the set, but it isn't changing the basic properties of the set, the elements that are in it. So that one's okay. Now, wait a minute. Look at create random set. That is mutable. This forces the set class to be mutable. The reason is that we're changing the elements object. So notice here when we reconstruct it and then we add new data to it, this is a mutation. Now, we might want to think about whether this is desirable or not. Would it be possible to do this in another way? If we want to make this an immutable class, we would have to change this method. The way we could do it is to make it a class method. So we wouldn't be dealing with the instance data in it, but instead just creating a new set object. It's actually not very hard to do. So that is something we might want to consider if we decide that it's wise to make the set class immutable. We have several create random methods, and so they're going to be very much the same. Create random element, notice, is a static method. Since it doesn't deal with the instance data, that cannot make the class immutable. Union, notice, was written in such a way that the union operation is immutable. We're not changing elements in it. And that's actually going to be true for the way we wrote all of our methods. So set difference, element of, is empty, complement. ToString, of course, is just taking the set and creating a string, so that shouldn't be changing the set. Equals, of course, is just making comparisons, so that's not going to change it. And here's another one that would. So when we have parse, notice this is changing elements. Now, would we be able to pull the same trick on this that we did on the other one? Well, yes, and in fact, we actually thought about this when we were doing our design. Remember I said that parse might work like parseInt in the math class? Well, if you think about it, parseInt, that's a class method, not an instance method. So it looks like we have made a couple of design mistakes. Now, the reason these design mistakes happened is because we didn't think about mutability or immutability soon enough in the design process. As a result, if we want this to be an immutable class, we would have to go back and maintain our code now. So that's why you think about these things earlier instead of later. And that's the end of the class. So there are actually only 2 tiny little changes we would have to make. And frankly, if I were doing this commercially, I would make those changes right now and have the class be immutable. Immutable classes are the source of far fewer programming bugs. And so you definitely want to make sure that you make as many classes immutable as possible. Let's talk a little bit about the big picture of the programming that we've done. The programming trick that we just used has a name. It's called a facade. That may be a word you're not too familiar with, so let me explain what a facade is. It's a fake front. So for example, if you go down the main street in Norman, Oklahoma, and you look at the buildings from the side, you'll see that some of the buildings are 1 story tall, but they have fake fronts on them to make them look like they're 2 stories tall, so that Main Street looks nice. This is exactly what we did. We hid an array list inside a set, and we did it successfully. In fact, somebody who's using the set would have no idea that that's what we did. So the trick here is to hide the implementation details from the external world. Remember that that's also good encapsulation. It appears to outsiders as if order is not important. Notice we actually checked that when we were checking our data, when in fact we're using a data structure that has order that is important. It's kind of a neat trick. If you're interested in tricks like that, there's a wonderful book called Design Patterns that you're going to really enjoy. You're not quite ready for it yet. You need another semester of programming to know enough programming techniques to make it understandable, and even then it is a major intellectual challenge, but it is a truly wonderful book. Now, one thing you may be wondering at this point, doesn't Java have a set class? Well, yes, actually it has several of them. It has a enum set, it has hash set, and it has tree set. Now, why didn't we use them? Well, one problem is complicated syntax. Another problem is the operations in the set classes were given kind of odd names. They weren't called union and intersection. Now, there are some very good reasons for this, and you'll learn those next semester if you continue to study Java. But that's one of the reasons. And of course, there's the fact that we needed to practice some implementation on our own, particularly dealing with instance methods versus class methods. Now, one thing you may be wondering here is why sets are important. It turns out that sets are the foundation of the mathematics of computer science. That's really counterintuitive. But if you think about it, an element is either in a set, like 1, or not in a set, like 0. It's binary. And that's why sets are the mathematical manifestation of binary digits. In other words, sets underlie everything we do in computer science. Now, this is a part of mathematics that you may not be particularly familiar with, called discrete mathematics. Mathematics is actually divided into 2 parts. There's continuous mathematics, which includes things like calculus, and most of algebra. So for example, between 2 points, there's always another point on the number line. Well, guess what? That doesn't work in computer science. Our whole world is in the other half of mathematics, which is the half of mathematics you probably have had very little exposure to. This is a source of great consternation for us computer scientists who would like to see junior high schools and high schools teach more discrete math because it's so useful in our field. So keep programming.